Fine, so here is an example where we're going to be looking at the specific heat capacity and also the latent heat of fusion, and it's a combination of the two, so it's quite an interesting question. So we have some data for ice and water are given below. We have the specific heat capacity of ice, the specific heat capacity of water, and the specific latent heat of fusion. Now don't worry about these subscripts. For some reason when I copy this over onto this file, all the subscripts drop down, but I think you can follow those. So we have a mass of 350 grams of water at a temperature of 25 degrees Celsius is placed in a refrigerator that extracts thermal energy at a rate of 86 watts. Now we know that 86 watts means 86 joules per second. It's going to be extracting that energy. Calculate the time for the water to become ice at -5 degrees Celsius. So what's happening to the water is it's going to start off at 25 degrees Celsius and it's going to go down to 0 degrees Celsius. There's going to be a change of temperature here of 25 degrees Celsius, and in this process it's going to be giving out energy because the kinetic energy of the molecules is actually going to be decreasing, so it's going to be giving out, it's got to lose energy in the process. You then have this situation over here. I'll just do it in a different color. You've got at this point over here, and I'm just going to do, the water will freeze. Now again it's going to give out energy because it's got the bonds are going to become more stable, and they're going to go to a lower potential energy, and so doing give out energy. So there's going to be further energy released there, and then we go from 0 to -5 where it's now ice. So this is ice, this is water, and the ice is now going to be 5 degrees Celsius. There's going to be a change in temperature of 5 degrees Celsius, and it's going to again give out energy, and this energy is going to be extracted at 86 watts, 86 joules per second. So let's see the energy loss, the Q lost, and let's take it one at a time, and this is very important to do in these problems. Let's firstly take the water. So that's going to be MC, change in T. Now the mass is 350 grams. Remember to always change this into kilograms because these are all given in kilograms, you see. So we've got to use kilograms because these are given in kilograms. So we have 0.35 times by the specific heat capacity. Obviously we're using these two formulas over here. Let me just write them up. That Q is equal to MC, change in T, and Q is equal to ML when you have a change of phase. So firstly, the Q loss for the water is 0.35 times the specific heat capacity of water, which is 4.2 times 10 to the 3 times 25 degrees, plus now we're going to have the energy lost when it freezes. So we're looking at that part. That's going to be the mass, 0.35. We're using this formula over here now, times the specific latent heat of fusion. That's going to be times 3.3 times 10 to the 5. Plus, now it's going into ice. So now we're looking at the energy loss when it cools further, 3.5 times 2.1 times 10 to the 3 times the change of temperature is 5. So we do that all on our calculator. We can do it all in one step. We don't need even any brackets. We can just put it in. So it's 0.35 times 4,200 times 25 plus 0.35 times by, that's 3.3 exponent 5 times, no sorry, not times, it's going to be plus 0.35 times by 2100 in this case, 2.1 times 10 to the 3 times by 5, and I get this number over here. I get 155,925 joules. Now that's the heat. So if we think of our formula, that power is equal to work or energy over time, time would equal the work, which is 155,925 joules, divided by the power, which is 86 joules per second. You see that your joules are going to cancel. Your s to the negative 1 is going to go to the top and is going to become seconds. So we divide this number by 86, and I get 1,813 seconds, and I can divide that by 60, and I can get in minutes. It's about 30 minutes. All of these are two significant figures. This is actually 30.2, so in saying it's 30, I've rounded to two significant figures. So that would be your answer for that one. Okay, thank you.